Hello everyone, and welcome back to the video lectures on rational expressions. So for this video, we are going to be starting the gradual process of adding and subtracting rational expressions. Now, like when you add or subtract regular fractions, you do need common denominators when you add or subtract rational expressions. So this section is going to be all about how to express fractions, rational expressions, in terms of the lowest common denominator, or LCD for short. So here's a little bit of a recap of what the lowest common denominator is. They are required for you to add and subtract fractions. So the lowest common denominator between two fractions is the least common multiple between the two denominators. The least common multiple between two numbers is the smallest number that is a multiple of both. Multiples are different than factors. Factors are numbers that go into another number. Multiples are what happen when you take a number and you multiply it by another. So for example, multiples of 6 are 6, and then 6 times 2 is 12, 12 times 3 is 18, and then 12 times 4 is 24. You get the idea. So in terms of least common multiples, sometimes the two numbers have a common factor that you can then take advantage of. Now, in the instance when one number is simply a multiple of another number, such as 5 and 10, then the least common multiple is simply the larger of the two numbers. So if one denominator goes into another, the lowest common denominator is going to be the larger of the two. And when the numbers have no common factors other than 1, then the least common multiple is the product of the two numbers. So for example, if one denominator was 2 and the other denominator was 3, the lowest common denominator would simply be their product 6 because they have no common factors. So we're going to do that process just with regular fractions first, and then we're going to move on to doing this with rational expressions. Now, I'm going to go about finding the lowest common denominator in a way that you are probably not used to, but this type of process is the same as the process that we are going to use to find the lowest common denominator when our denominators involve variables. So taking a look at 3/4 and 1/6, let's take a look at the two denominators that we have, 4 and 6. 4 and 6 have a common factor. They are both divisible by 2. So we are going to take advantage of that. Now, the lowest common denominator is not simply going to be 24. There is a denominator that is smaller than this. And anytime that you add or subtract any sort of fraction, whether it's a regular fraction or fractions with variables, you need to use the lowest common denominator. So here's what I'm going to do. I'm going to express both the 4 and the 6 as a product of that common factor 2. So for example, 4 is 2 times 2. And then 6 is 2 times 3. So there is that common factor of 2 between them. So since they already have this common factor, that is part of the denominator that they already have in common. Now, this second denominator has a 3 in it. The first one does not. So I'm going to fix that by taking both the top and the bottom of the first fraction and multiplying them both by 3. Remember, whatever you do to one part of a fraction, you must do the same thing to the other. So whatever you do to the bottom of one fraction, you must do the exact same thing to the top. Now, do the denominators completely match yet? No. This first denominator has 2 2's and the second denominator only has 1. So I'm going to fix that by multiplying that second denominator by 2. Then whatever you do to the bottom, you need to do the exact same thing to the top. Hold on, I think the subtitle stopped. Give me a second, I gotta fix that. Alright, I think we might have gotten the subtitles working. Nope, I spoke too soon. Nope, wait, there it goes. Hopefully it'll continue to just work. Anyway, so now let's take a look at these two denominators. 2 times 2 times 3, and then 2 times 2 times 3. Since order doesn't matter with multiplication, it really doesn't matter if they're in different orders, so these two denominators now match. So what we're going to do is we are going to simply do all of the multiplying. So 3 times 3 is 9 over 12. And then the other fraction is going to be 2 over 12. Now for this next one, for 1/2 and 1/3, if you take a look at the two denominators, 2 and 3, 2 and 3 have no common factors other than 1. So because of that, the lowest common denominator is simply going to be their product. So what I'm going to do with both 1/2 and 1/3 is I'm going to multiply each denominator by the other. So I'm going to take this 2 and I'm going to multiply it by 3. Whatever you do to the bottom, you need to do to the top. Then I'm going to take this 3 and I'm going to multiply it by 2. Whatever we do to the bottom, we need to do to the top. So 1 times 3 is 3 over 6, and the other fraction will be 2 over 6. And then for this last one, if you take a look at the two denominators, 5 and 10. Well, the smaller denominator 5 goes into the larger denominator 10. So since 5 goes into 10, this is an instance where one denominator is simply a multiple of the other. 10 is a multiple of 5. So when that happens, the lowest common denominator is simply going to be the larger one. So what you'll ask yourself is, okay, what do I multiply 5 by to turn it into 10? Well, I multiply 5 by 2. So I'm going to multiply that 5 by 2. Whatever you do to the bottom, you need to do to the top. And that's it. You don't even need to touch this second fraction because this second fraction already has our common denominator 10, so we're just going to leave it like that. So then, expressed in terms of common denominators, we have 2 over 10, and then the other one is going to be 3 over 10. We're going to use that same basic premise when we find the lowest common denominator when there are variables in the denominator. So my suggestion is to factor both denominators completely. This should be the first thing that you do. Because once both denominators are completely factored, you're going to take advantage of any common factors that are between them. If there is already a common factor, that is one less part about the denominators that you have to make match. So then you're going to make both denominators match by multiplying. So you should really ask yourself, what does one denominator have that the other doesn't? What does this denominator have that the other denominator does not? And so after some multiplying, you are going to make the denominators exactly the same. Now remember, whatever you do to the bottom of a fraction, you must do the exact same thing to the top. So if you're going to multiply the denominator by something, you need to multiply that exact same thing to the top. Now remember, you are using common factors, not common terms. Let's give this thing a second. Oh, what is going on? Excuse me, I gotta pause this again. Alright, I'm hoping that this is not going to be a thing through this whole video because that will get really annoying. Anyway, so we're going to take these two rational expressions and we are going to express each of them in terms of the lowest common denominator. Now keep in mind the whole point of doing this is to eventually be able to add and subtract these. I don't want to throw too much at you all at once, so we're just going to focus on finding common denominators for this section, and then in the next section we will actually be taking that a step further and then adding and subtracting rational expressions. So that is eventually where this is going. Eventually there will be either a plus sign or a minus sign between these two expressions. So let's focus on the common denominator part first. So what I would recommend is factor anything that looks even vaguely factorable. So for x squared minus x minus 6, there's going to be an x here and an x here. And we're looking for two numbers that multiply to -6 and add up to -1, which are -3 and +2. Then for the other denominator, x squared minus 9, this is a difference of squares, so we have x minus 3, and then x plus 3. So if you take a look between these two denominators, they do have a common factor, x minus 3. So this x minus 3 is a common factor between these two denominators. Take advantage of that. However, if you take a look at the first denominator has an x plus 2 in it. The second denominator does not. So I'm going to fix that by multiplying the second denominator by x plus 2. And then, whatever you do to the bottom of a fraction, you need to do the exact same thing to the top. So, do the denominators completely match yet? No. So if you take a look at the second denominator has this x plus 3, and the first one does not. So I'm going to fix that by taking this first denominator, and I'm going to multiply it by x plus 3. Then, whatever you do to the bottom, you're going to do the exact same thing to the top. So you're going to multiply the top by x plus 3. Now, it doesn't matter if the factors in the denominator are in different orders, as long as they all have the same factor. So we've got that x minus 3 in common. This first denominator has an x plus 2, so does the second one. The first denominator has an x plus 3, and so does the second one. So both denominators have an x minus 3, an x plus 2, and an x plus 3. So the denominators are now common. Now, as far as simplifying goes, my number one suggestion for this entire process, even when we get into adding and subtracting, is to leave the denominators alone. You do not have to distribute the denominators. You can leave the denominators as x minus 3 times x plus 2 times x plus 3. It really doesn't matter. I am not going to make you distribute this. However, please distribute the numerators. So distribute the numerators, and if there's any simplifying to do, go do it. So I'm going to distribute this 2 to this x plus 3. So 2 times x is going to give us 2x, and then 2 times 3 is going to give us plus 6. And then for the other one, 1 times x plus 2 is going to be x plus 2. And remember, we are going to just leave the denominator alone. So we're going to leave the denominator as x minus 3 times x plus 2 times x minus 3. Sorry, x plus 3. And remember, it really doesn't matter what order these factors are in, as long as they are all there. So we're basically going to do that same thing for this next one. Now, this negative that's in front, we're going to talk more about negatives and what to do with subtraction when we actually get to that part in 6.3. So for now, we're just going to leave this negative alone. So the first thing that we're going to do is we are going to factor both denominators. So for the first denominator, since that is a 1x squared, there is an x here and an x here. And then we're looking for two numbers that multiply to positive 9 and add up to negative 6, which are minus 3 and minus 3. And then for the other one, since that is a 1x squared, there's going to be an x there and an x there. And we're looking for two numbers that multiply to negative 3 and add up to negative 2, which are minus 3 and plus 1. So then if you take a look at these two denominators, they do have a common factor. They have an x minus 3 in common. However, the first denominator has two of these x minus 3 terms. It's an x minus 3 times another x minus 3. The second denominator only has one. So I'm going to fix that by multiplying the second denominator by another x minus 3. Whatever you do to the bottom, you need to do the exact same thing to the top. So now both denominators have an x minus 3 times another x minus 3. However, this second denominator has an x plus 1 and the first denominator does not. So I'm going to fix that by multiplying the first denominator by x plus 1. Whatever you do to the bottom, you need to do the exact same thing to the top. So then we'll just double check to make sure that the denominators all have the same factors. So x minus 3, x minus 3, x plus 1. X minus 3, x minus 3, x plus 1, they both have the same factors. So for the simplifying, remember you can leave the denominators alone. And if you want to write the x minus 3 times itself as x minus 3 squared, you're more than welcome to. You don't have to. The big thing is to make the denominators match. But what we are going to do is we're going to do any distributing needed to the numerator. So 1 times x plus 1 is x plus 1. And then for the other fraction, again, I'm going to leave the denominator alone, and I'm going to write this as x minus 3 parentheses squared times x plus 1. And I'm going to distribute this 4 in the second numerator. So 4 times x is going to give us 4x. And then 4 times negative 3 will give us minus 12. So this is what the two fractions look like expressed in the lowest common denominator. Now for this next one, whenever you are factoring, remember you should always look for greatest common factors first. I'm looking specifically at the denominator of the first fraction. The denominator of the first fraction, both of these terms contain an x, so there is a GCF of x between these two. So I'm going to factor out that GCF, so when I factor an x out, I am left with 2 minus x. And then for the other fraction, I'm looking for two numbers that multiply to -6 and add up to +1, which are +3 and -2. Now, if you take a look at this, they almost have a common factor. This second denominator has an x plus 2, an x minus 2, and this first denominator has a 2 minus x. Remember, order does matter with subtraction, so you can't just switch the subtraction, but they are extremely close. So if you want to switch the order of the subtraction for this 2 minus x, remember you can, as long as you factor out a GCF of -1 first. We've covered things like this in the past, so this is going to be somewhat of a review. So if you factor out a -1, you can then change that denominator to x minus 2. And then the other fraction is still going to remain x over x plus 3 times x minus 2. And then for this negative that is in the denominator, the -1 that you had to factor out in order to switch the subtraction, finding common denominators is hard enough as it is. So when you have a negative like this that is being multiplied, as long as the negative is somewhere in the fraction, the whole fraction will count as negative. So what you can do with this is just put the negative here in the middle. This way you don't have to worry about it for your common denominators, because it doesn't matter where you put it. Anytime that you have a negative being multiplied, it can move to the numerator, it can move off to the side. Just get in the habit of keep it off the denominator. Common denominators are hard enough as it is. So now that we've gotten that taken care of, you will notice that these two denominators now have a common factor of x minus 2. There's an x minus 2 here and an x minus 2 here. So we are going to make the two denominators match. Now you'll notice that this second denominator has an x plus 3, whereas the first one doesn't. So I'm going to fix that by multiplying that first denominator by x plus 3. Then whatever you do to the bottom, you need to do the exact same thing to the top. So I'm going to put parentheses around that 2x minus 1, and then I'm going to multiply it by x plus 3. Then, remember that GCF that we took out at the beginning? Well, when you take out a GCF, you write it with multiplication. Anything written with multiplication is considered a factor. So this standalone x right here is technically considered a factor. So this first denominator has that standalone x, whereas the second one doesn't. So I'm going to fix that by multiplying both the top and the bottom of this fraction by x. I gotta deal with whatever this is. Give me 1 second. All right, let's try that again. I'm also sorry with the number of technical problems that we've been having with this particular lecture series, so let's hope that that's the end of it. All right, anyway, so what we are going to do at this point is we are going to do any distributing in the numerators, because in the denominators we have x plus 3, x plus 3, x minus 2, and x and x. So again, you can leave the denominator alone, so you can leave the denominator as x times x minus 2 times x plus 3. And then we're just going to distribute the numerators and kind of simplify as we go. And then keep in mind there is a negative in front of here. So 2x times x will give us 2x squared. And I'm going to kind of combine the middle terms as we go. So 2x times 3 is 6x, minus 1x will give us plus 5x. And then -1 times 3 is minus 3. Then for the other fraction, again, you can leave the denominator alone. You do not have to distribute the denominator. And then you're just going to multiply x times x, which is x squared. So this is what these two fractions look like expressed with a common denominator. So then for this next one, it's going to be basically the same idea. We're going to factor the two denominators, and then we're going to use multiplication to make the denominators match. However, for the factoring, I want to point out in the denominator of the second fraction, the leading coefficient is negative. So remember, if your x squared term is ever negative, to make your factoring easier, factor out a GCF of -1 first. So that's what I'm going to do here. I'm going to take the denominator of the second fraction only, and I'm going to factor out a -1 to give us x squared minus 25. So now that we've gotten that out of the way, now we can go about factoring. So I'm going to put parentheses around that x plus 4. And then to factor x squared minus 3x minus 10, we are looking for two numbers that multiply to -10 and add up to -3, which are -5 and +2. And then for the other fraction, remember, if you ever have a negative that is being multiplied and it's in the denominator, do yourself a big favor and put it here in the middle so you don't have to think about it anymore. So we're going to factor x squared minus 25. This is a difference of squares. It is x minus 5 times x plus 5. So then there is a common factor here of x plus 5. So we're going to take advantage of that. Now this second denominator, the common factor is x minus 5. The second denominator has an x plus 5 term, whereas the first denominator does not. So I'm going to fix that by multiplying that first denominator by x plus 5. Whatever you do to the bottom, you have to do to the top. So I'm going to multiply the top by x plus 5. Then for the second denominator, you might notice the first denominator has an x plus 2, whereas the second one doesn't. So I'm going to fix that by multiplying that second denominator by x plus 2. And whatever you do to the bottom, you have to do the exact same thing to the top. So for your two fractions, what you're going to do is you're going to distribute the two numerators. And then you are going to just kind of leave the denominators alone. So the denominator is just going to be x plus 5 times x minus 5 times x plus 2. So for the first numerator, x times x is going to give us x squared. Then x times 5 is 5x, plus 4x is going to give us plus 9x. And then 4 times 5 will give us plus 20. Then for the second fraction, again, the denominator is going to be the exact same with the negative out front. So we have x plus 5 times x minus 5, this is a little squished, times x plus 2. Then for the numerator, we're going to distribute 2x. So 2x times x is going to give us 2x squared. And then 2x times 2 is going to give us plus 4x. Now for this next one, this is an example where the two denominators have no common factors. So there's nothing to factor here. Everything's already as factored as it's going to get, and I am going to put parentheses around each of these because x plus 5 is a factor and x minus 3 is a factor. So they have no common factors, and it doesn't matter that they both have an x in them. That is a common term, not a common factor. Common terms do not count. They have no common factors. So if you might remember from the example that we did with regular fractions, when the two denominators have no common factors other than 1, the lowest common denominator is simply going to be their product. So I'm going to take this first denominator and I'm going to multiply it by the other fraction's denominator. I'm going to multiply it by x minus 3. And whatever you do to the bottom, you need to do the exact same thing to the top. Then for x minus 3, I'm going to take this second denominator and I'm going to multiply it by x plus 5. And whatever you do to the bottom, you need to do the exact same thing to the top. So then, again, you can leave the denominator alone. You do not have to FOIL the denominator. You can leave it as x plus 5 times x minus 3. For reasons that we will get to when we actually go adding and subtracting these, you do want to distribute the numerators. So 1 times x minus 3 is going to give us x minus 3. And then for the other fraction, again, the denominator is just going to be x plus 5 times x minus 3. And we're going to distribute this 2x in the numerator. So 2x times x is going to give us 2x squared. And then 2x times 5 is going to give us plus 10x. So there are the two fractions expressed in terms of the lowest common denominator. Now for this next one, we're going to do some factoring first. So I'm going to go ahead and factor that first the first denominator. So for the first denominator, we're going to look for two numbers that multiply to -2 and add up to +1, which are x plus 2, and then x minus 1. Now you might notice that the denominator of the second fraction, there's really nothing to do here. There's only an x plus 2 here, and that is it. So yes, these two denominators have a common factor. They have a common factor of x plus 2. But even more than that, this is an instance where one denominator is simply a multiple of the other. The only difference between these two denominators is this x minus 1. The first denominator is being multiplied by the x minus 1, whereas the second one is not. So I'm just going to quickly fix that by multiplying that second denominator by x minus 1. Whatever you do to the bottom, you need to do the exact same thing to the top. And that's it. We don't even need to touch the first fraction. The denominators already match. So since the denominators already match, I'm just going to go ahead and simplify the numerator of that second fraction, and then we're going to call it good. So your common denominator is going to be x plus 2 times x minus 1. And the only simplifying that you need to do at this point is distribute the numerator. So x times x is going to give us x squared. X times -1 is minus x. And that's it. You didn't even need to touch the first fraction apart from factoring it. So keep an eye out for each of those special cases whenever you are finding lowest common denominators. Now for this next one, the factoring has already been done for us. In this first denominator, it does look like there was already a greatest common factor of x that was taken out. Now remember, this x, there is hidden multiplication here. This x is being multiplied by this x minus 3. So because of that, this standalone x that's right here is technically considered a factor, and it will need to be factored in when you're finding lowest common denominator. So to make the denominators match, we're going to use some multiplication. Now, let's start with the obvious. The first denominator has an x minus 3, the second one does not. So I'm going to multiply the second denominator by x minus 3, and then whatever you do to the bottom, you need to do the exact same thing to the top. However, that's not it, because the two denominators are very similar, but they are not exactly the same. The big difference is that this is an x squared and this is not. So again, because these are being multiplied, these standalone x and x squared here are technically considered factors, and this is an x squared and this is an x to the power 1. So we do need to make the denominators match. We need to turn this x into x squared using multiplication. So what do you multiply x by to turn it into x squared? Well, you're going to multiply it by another x. So I'm going to multiply this first denominator by another x, and then whatever you do to the bottom, we're going to do the exact same thing to the top. So now x times x will give us x squared times x minus 3. And then over here, x squared times x minus 3, the two denominators match. So x times x will be x squared times x minus 3. And we're just going to mainly focus on simplifying the numerators. So 1 times x is just going to give us x for that first numerator. Then second denominator is going to be x squared times x minus 3. And then to simplify the numerator, we're going to distribute the 6. So 6 times x is going to give us 6x. And then 6 times minus 3 will give us minus 18. And there you have it. There are your two fractions expressed in the lowest common denominator. So for this next one, there's no factoring to do in the first fraction, but we are going to put parentheses around the x minus 5 because it is considered a factor. First thing that we're going to do is we are going to factor the denominator of the second fraction. X squared minus 25 is a difference of squares, and it is going to factor as x minus 5. times x plus 5. So yes, they do have a common factor of x minus 5. There is an x minus 5 in both of them. This is another one of those instances where one denominator is simply a multiple of the other. The only difference between these two denominators is this x plus 5. So I am going to give the first fraction an x plus 5 by multiplying. So I'm going to multiply that first denominator by x plus 5. And then whatever you do to the bottom, you're going to do the exact same thing to the top. And that's it. You didn't even need to do anything with the second fraction apart from factoring it. The two denominators now match. You do not have to multiply the second fraction by anything. So what we're going to do is we're just going to kind of leave the denominator as x minus 5 times x plus 5. And I'm just going to simplify that first numerator by distributing the 3x. So 3x times x is going to give us 3x squared. And then 3x times 5 will give us plus 15x. And then for the second fraction, we didn't need to do anything in order to give it a common denominator. So the second fraction will remain as 4 divided by x minus 5 times x plus 5. So then for this next one, it definitely looks like we have a lot of factoring to do. So let's do some factoring. And I'm going to put parentheses around this x minus 1 to kind of keep it together. So first fraction, I'm going to put parentheses around the x minus 1, and then we are going to factor the denominator. So because that is a 1x squared, there's going to be an x here and an x here. And then we're going to look for two numbers that multiply to negative 15 and add up to positive 2, which are going to be plus 5 and minus 3. Then for the second fraction, since that is a 1x squared, we have an x here and an x here. And we're looking for two numbers that multiply to 5 and add up to 6, which are x plus 5 and x plus 1. So the two denominators have a common factor. There is an x plus 5 in both of these. So let's just use some more multiplication to make the two denominators match. Now the second denominator has an x plus 1. The first one does not. So to fix that, I'm going to multiply that first denominator by x plus 1. Whatever you do to the bottom, you need to do the exact same thing to the top. Then the first denominator has an x minus 3 and the second one doesn't. So I'm going to multiply that second denominator by x minus 3. And then whatever you do to the bottom, you need to do the exact same thing to the top. So it doesn't matter if the factors are in different orders: x plus 5, x plus 5, x minus 3, x minus 3, x plus 1, x plus 1. The two denominators are exactly the same now. So what we're going to do is just simplify the numerators, and we're just going to leave the denominator alone. You can go ahead and leave it as x plus 5 times x minus 3 times x plus 1. And in the numerator of the first fraction, we're going to fully distribute. So we've got x times x, which is x squared. X times 1, which is 1x, minus 1x, cancels out. And then negative 1 times 1 is minus 1. And then for the other fraction, again, we're just going to leave the denominator as x plus 5 times x minus 3 times x plus 1. And we're going to distribute this x to the x minus 3. So x times x is x squared, and then x minus 3 is minus 3x. So these are the two fractions expressed in terms of the lowest common denominator. Now remember, the whole point of this is we will eventually be using this process to add and subtract rational expressions. So there will come a time where instead of an and between them, there will either be addition, a plus sign, or subtraction, a minus sign. So please make sure that you work on and finish the 6.2 homework first before you move on to 6.3. Make sure that you are good with finding common denominators and this whole process of expressing fractions in terms of the lowest common denominator before you then have to use it for addition and subtraction. So addition and subtraction of rational expressions is going to be in its own separate video. Thank you all very much for watching, and as usual, if you have any questions about anything from this video, please feel free to email me, and I will see you in the next one. Bye-bye.